Let's go through code 1404. Number of steps to reduce a number in binary representation to 1. Given a binary representation of integer as the string s, return the number of steps to reduce it to 1 under the following rules. If the current number is even, then you divide it by 2. If the current number is odd, then you have to add it to 1 to it. We'll see this string has length 5 to be about 500, right? So we should actually convert to length 500 big integer should not be a good way, right? We should do it using string, should be a better way. And the things that you say that if it is even, that means this number is ended with 0, right? So we just divide by 2. That means we just remove the last zeros with it, and we add one more operations. But if it is 1, right, what we do? End with 1. What we need is we need add 1 to it. So add 1 to it. What the effect is that we need find the last zeros from the right, and change this 0 to 1, and change the rest to be 0. So this is one operation, right? And for example, this index is I. And we'll say in the doing like this, we can change set this one to be 1, right? And set the rest to be 0. But the thing is that if this kind of number, it is always 111, right? So what we do is that because this last index of 0 will be -1, right? So what we do is that we need just a return we should doing like add 1 here and change the rest to be 0, 0, 0, right? But here there is a for loop, so seems not that efficient. So what we're thinking about is that we'll say this is one operation, right? Change this to be 1, and here 0 I will index this is I, and now it's become even number. So how many zeros after I? That is n -1 minus I zeros, right? So that is n -1 minus I plus 1 plus 1. So that is n -1 minus I zeros. So that is the even number operation, n -1 minus I, right? But there is also an odd number operation that is change the last 0 to be 1, right? And so we add one more operation, and then remove all of these kind of zeros. So if it is an odd number, what we think about is that we find the last index of 0, and then we have n minus I operations, and remove all of these ones, right? And we also need to change this one to be 1. There is one corner case for odd number is that all of the number is 1111, right? So this index 0 will be -1, right? The operation will still be n minus last index of 0, but we cannot change but the length, right? Doing like this, our if we use set length, right, it will be 0. So so we are only set the last chart to be 1 only when this length is greater than 1, right? So let's write code for this. We should convert this one as string builder because we have a lot of strings. And if the result goes to 0. So while this kind of string builder dot length is greater than 1, right? So we'll say if this is even number, that is string builder char at the length equals string builder dot length. If this one char at length minus 1, if this one equals 0, right? Means this is an even number. We just set string builder set length minus 1. First, yeah, so we need to have the last 0, right? Last 0 equals string builder dot char last index of 0. We know we result should have plus equal to length, string builder dot length minus plus 0. And now we should set its length, right? String builder set length. That is last 0 plus 1. And we are, if this length is greater than 0, then we'll set the last from the last element to 1, right? If string builder dot length, current length is greater than 0, we are going to have a string builder set char at string builder dot length minus 1 to be 1. And in the end, return result. Set this length to be set last index of arrow length minus last 0. And set this length to be equals string builder length. We should have result increased by 1, right? And let's convert this one to Python code as well. String builder, let's change this one to be a list of string because we want to remove some of the characters result equals to 0, right? So what's the while sp length sp is greater than 1. We'll say if sp the last character is 0, right? Then we have sp dot top the last one. And we have result the plus with 1. Else we have last 0 equals length SB um, minus um, -1 minus SB. We use a reverse order in the index here, right? That is from the last element, right? We find the index of 0 from the reverse order. So if this is 0, right? So that is n minus 1. We get its index. This is length minus 1, right? So if this is 1, that is this kind of index minus 1, right? So we have result should plus equal to length SB minus last, yeah, okay. And we are going to have set this kind of string builder equals string builder plus the 0 plus 1. We just cut to this last plus 0, right? So we'll say if length SB is greater than 0, we'll just set the last element string builder plus minus 1 to be 1. In the end, we just return result. Mm, 9, 11. Zero is not in list. Yeah, it's not in list. I think the problem is that this one, right? This one does not have, this is correct. So which one doesn't have 0? 0 not in list. The thing that because we are not able to find zeros, right? So mm, if mm, 0 in SB, right? Then if 0 in SB, this one will always have length, right? So we'll do this. Otherwise, yes, we just um need a return the string builder dot length plus 1, right? So result is plus equal to string builder length builder plus 1, yeah. And we should return result, right? Otherwise, it will not terminate.